Okay, this is lesson 5.5, functions and inverses. The idea here is students will perform operations on functions and find the inverses of functions. So to first start this, we're going to talk about what a function is. And it's helpful to think of a function as some sort of machine that does things to numbers. So you can input something that's usually the x, and it's going to output something else. It's going to do something to that number and spit something else out. In this case, it takes in a 5 and spits out a 12.8. Okay, so this is going to do this no matter what the number is. It's going to do the same thing to it. The product won't be the same because the raw materials that are coming in aren't the same. But whatever raw materials come in, the function does something to it, some operations, and spits out something else. Now, if I just tell you what the inputs and outputs are, it's not going to be too helpful figuring out what the function is doing. So most of the time we write the function as an equation. In this case, I have y equals 4 minus x squared. Now if I write it like this, it's helpful to think of we are familiar with y and x, but there's nothing technically that is telling me what the input and output of this function is. So generally I write it like this. In function notation, instead of a y, we write with f of x. Now that tells us that we're dealing with a function, and the variable that you put into the function is the variable x. This means it's a function of the variable x, but usually when we see that, we just write f of x. Now we can do things with functions, the same kind of things we can do with numbers. We can add or subtract functions. So in this case, I have f of x is 3x plus 8, and g of x is gx minus 12. So if I'm going to find f plus g of x, or f minus g of x. So first I'm going to do f plus g of x, and that is just a shorthand notation of writing f of x plus g of x. So in this case, f of x is 3x plus 8, and g of x is 2x minus 12, so I add them together. Be careful when you plug in, always use parentheses, because it's better to use parentheses, because if you have them and don't need them, that's better than needing them and not having them. Now in this case, since I have all pluses, I don't need parentheses, so I can just put 3x plus 8 plus 2x minus 12, and I combine like terms. 3x plus 2x turns into 5x, and 8 minus 12 turns into negative 4, so I have 5x minus 4. Now f minus g of x, again, it's f of x minus g of x. So I plug them in. The f of x is 3x plus 8, the g of x is 2x minus 12, and this time I subtract those, so I have to distribute that second minus sign. So this becomes 3x plus 8 minus 2x plus 12. So I have 3x minus 2x, that's x, and 8 plus 12 is 20. So this is x plus 20. So that's adding and subtracting. Another thing I can do with functions is I can multiply them. So in this case, I have f of x is x squared minus 1, and g of x is x plus 1, and I'll find f times g of x. F times g of x is just going to be f of x times g of x, which in this case is x squared minus 1 times x plus 1. Now in this particular case I have to FOIL because I have two binomials that I'm multiplying together. So x times x squared is x to the third, x squared times 1 is x squared, negative 1 times x is negative x, and negative 1 times 1 is negative 1. Since all those have different exponents, they can't be combined, and I'm done. The other thing I can do with functions is I can make a composition function. And that's when you plug one function into another function. So in the case of this, I have f of g of x, which I can write as f(og) of x, because that little o means of. So what I'm doing here is I'm replacing the x in the f of x function with the entire g of x function. So I'm essentially plugging the g into and replacing the x with f and the f. So as an example, I have f of x equals x minus 2 and g of x equals x squared. Now I want to find f of g of x. So what I do is I plug in g of x and replace the x in the f of x with that. So I'm plugging the g into the f. So since the f is x minus 2, if I replace the x with g of x, I get g of x minus 2. But I know what g of x is. G of x is x squared. So I can again replace the g of x with x squared. And again, whenever you do this, try to use parentheses. So I have x squared minus 2, and I don't need the parentheses in this case, so that's just if I plug in g of x into f of x, I get x squared minus 2. Next thing is about inverse functions. So inverse functions basically undo whatever the function does. So we talked about the function as being like a factory. So this factory takes in at 5 and puts out a 25. The inverse is going to take that 25 and turn it back into a 5. So if I run something through the function and the inverse, it gives me back my original thing. So it does the opposite of whatever the function does. So the input of the function is the output of the inverse, and the output of the function is the input of the inverse. So how can I tell if two functions are inverses of each other? These two are pretty obviously inverses, and I'm going to use that idea to see what happens when I make a composition out of two inverse functions. So in this case, I'm going to replace the x in the g of x with the entire f of x function, so x minus 300. So I'm plugging gf into g. So this is g of f of x. When I do that, I get x minus 300 plus 300. Clearly the 300s cancel out, and I'm left with x. So those are inverses. So if I plug f of x or g into f of x, or the other way around, and when I simplify that, if I can get x by itself with nothing else, then those are inverses. Any other answer is going to give me two functions that are not inverses of each other. So an example, I have f of x and I have g of x. This time I'm going to plug g into f. So I replace the x in f with the x minus 2 that makes up the g function. So that becomes 2 times x minus 2, which is 2x plus 4, which is not x. So these are not inverses of each other. The other thing we have to do is be able to find the inverses of a function. So to find the inverses of a function, since an inverse has the opposite inputs and outputs of the original function, I make it look like y. So I have y equals 7x minus 5. And I switch the places of the x and the y. So this becomes x equals 7y minus 5. Now I have to get the y by itself. So I add 5 to both sides. I get x plus 5 equals 7y. I divide by 7. So I get x plus 5 over 7 equals y. So that's the inverse function. X plus 5 over 7 is the inverse function of that original f. So that's the end of the work. Here's your 2 pages of homework. I'll see you next class, and good luck.